Okay, so the words would be random walks on percolation clusters. So let me try and explain just a bit what that would be. So imagine that you've got a city laid out as a rectangular grid. And you can imagine a random walker as somebody who walks along a street, and when he gets to an intersection, he tosses a coin, and he goes in each of the four directions with equal probability, which would be 1/4. So this is a model which was studied early in the 20th century, and for example, somebody called Polya showed that you would return to your starting point again and again in such a model. Now, the percolation model imagines that now some of these roads are being dug up, so you randomly block some of the roads. So now the random walker, when he goes along a road, he might find that 2 of the, or even 3 of the roads that he would like to go out on are blocked. So then he has a restricted number of choices, and these blockages may mean that the random walker takes a much longer time to cross regions. So we now have mathematical techniques to study problems like this. I mean, the model I've shown you there is a kind of idealization, but these models would also apply to fluids diffusing in media with blockages of various kinds and so on. Okay, so it's in probability theory and also in an area called partial differential equations. In fact, one of the contributions I made in this area was to realize that techniques which have been developed by people in the PDE community, going right back actually to the 1950s, were of use in solving this problem in probability theory. Well, I sort of drifted into it. In fact, I think I come from a sort of fairly scientific family and so I always wanted to be a scientist. And I think if you asked me at 12, I would have said astronomy or physics rather than mathematics. But as I grew older, mathematics became attractive, and I sort of just moved into that area by sort of, I suppose, it's a process of narrowing down options of what I wanted to do. Well, I think very promising. I mean, there are a huge number of mathematicians in the world, and what we've seen perhaps in the last, in my lifetime in mathematics, is many problems which were long-standing and looked very hard to solve. One of them would be something called the Poincare conjecture, have been solved. So mathematics is making huge progress in its own terms, in terms of mathematical theory, but also we're seeing developments of mathematics in all kinds of areas for handling problems which arise in technology, in data analysis, in all kinds of ways. So I don't see any reason to say, well, let me put it again, I think the future of maths is very promising.